Have you ever wondered how a video game calculates your score? Or how an app on your phone can possibly predict traffic? Well, the secret sauce behind all of that is a powerful language called algebra. So today, we're going to demystify that language, starting with its most basic building blocks, algebraic expressions. So what if math really did have its own language? Well, guess what? It does, and it's called algebra. And it's the language we use to describe the world around us in this really precise, powerful way. By the end of this, you'll be able to read and write in this language, and you'll be on your way to solving all sorts of fascinating problems. Here's our game plan. First up, we'll meet the basic parts of an expression. Then, we'll see how those parts come together to build different structures. After that, we'll get into the rules of the game and actually put our knowledge to the test. And for the grand finale, we'll uncover some of algebra's coolest shortcuts. Let's jump in. All right, let's kick things off with the absolute basics. In this first section, we're going to zoom in on the fundamental pieces that make up every single algebraic expression. So, the very first building block you've got to know is the variable. The easiest way to think about it is like a box that can hold any number. We don't know what number is inside the box just yet, but we can still work with it. And we usually use letters, like X or Y, to represent these little mystery boxes. So, here's a variable in its simplest form. Just X. That's it. It's a placeholder, our mystery box, just waiting for a number we haven't figured out yet. Okay, but what if you want to talk about having more than one of our mystery boxes? That's where this next piece, the coefficient, comes into play. It's just the number out front that tells us how many of a variable we're dealing with. For instance, if you see 5x, that 5 is our coefficient. It's telling us, hey, we have 5 of those x variables. So we're not just looking at one mystery box anymore, we're now looking at a whole group of 5. Now, when you put a coefficient and a variable together like that, you get something called a term. Think of terms as the individual words in our new algebraic language, and you'll always find them separated by plus or minus signs. Let's look at a full expression to see this in action. 5x plus 3y minus 7. Here, the words or the terms are 5x, 3y, and negative 7. The coefficients are 5 and 3. And that negative 7 hanging out at the end? That's a special kind of term we call a constant, just because it doesn't have a variable attached. Its value is always, well, just negative 7. Okay, so now that we know what terms are, let's look at how we classify expressions based on how many terms they have. It's kind of like learning the difference between a single word, a phrase, and a full sentence. The names really give the game away here. Mono means one, so an expression with just one term, that's a monomial. Bi, like bicycle, means 2, so an expression with 2 terms is a binomial. And tri, like triangle, means 3, so an expression with 3 terms is a trinomial. Simple, right? And pretty much any expression with more than one term can just be called a polynomial. Poly just means many. Okay, so we know the building blocks, and we know how to name the structures. Now it's time to learn the rules of the game. Just like any language, algebra has its own grammar that tells us how we can put all these pieces together, and more importantly, how we can move them around. 2 of the most important grammar rules are the commutative and associative properties. The commutative property is super simple. It just says you can add or multiply numbers in any order you want. 2 plus 3 is the exact same as 3 plus 2. Then there's the associative property, which says you can group numbers in any way. So adding 2 plus 3 first and then adding 4 is the same as adding 2 to the result of 3 plus 4. These rules give us a ton of flexibility. And then there's the distributive property. This one is a huge deal. It tells us exactly how to handle multiplication when you've got a sum trapped inside parentheses. The basic rule is a times b plus c is the same as a times b plus a times c. Let's see how that actually works. To multiply 2 by the quantity x plus 3, we distribute that 2 to both of the terms inside. You got to share the multiplication with everyone. So 2 times x gives us 2x, and 2 times 3 gives us 6. Put it together, and the result is 2x plus 6. Okay, we know the rules of the game, so let's actually put them into practice. In this section, we're going to learn how to add, subtract, and multiply these algebraic expressions. This is where it all comes together. Now, before we can add or subtract anything, we have to talk about like terms. And it's really simple. You can add apples to other apples, but you can't add apples to oranges. In algebra, like terms are terms that have the exact same variables and exponents. The numbers out front, the coefficients, they can be different, but the variable part has to be a perfect match. Now listen up, because this is a really crucial point where a lot of people get tripped up. Adding and multiplying terms work very differently. When you add like terms, say 5x plus 3x, you just add the coefficients and keep the variable part exactly the same. So 5x's plus 3x's gives you 8x's, 8x. But when you multiply the coefficients and the variables. So 5x times 3x becomes 15x squared. See the difference? It's a big one. All right, you've got the fundamentals totally down. So how about we learn some really smart shortcuts? In algebra, there are these special patterns called identities that can help us solve problems so much faster. These 3 identities right here are basically cheat codes for algebra. Seriously, they pop up all the time. If you can commit these to memory, you'll be able to solve problems way, way faster without having to slog through all the multiplication steps every single time. And here's a handy little trick for remembering that first identity, the a plus b squared one. Just follow this pattern in your head. Square the first term, double the product of the 2 terms, and then square the last term. Easy as that. And this shortcut is so powerful you can actually use it for mental math. For example, if you wanted to calculate 104 squared in your head, just think of it as 100 plus 4 squared. So you square 100, that's 10,000. Double the product of 100 and 4, that's 800. Square the 4, that's 16. Add them all up, 10,816. Boom, no calculator needed. So let's do a super quick recap. We've learned that expressions are built from variables, coefficients, and constants. We figured out how to classify them by their number of terms. We went over the core rules of the game, like the distributive property. We learned we can only add or subtract like terms. And finally, we uncovered some powerful identities that act as awesome shortcuts. You see, algebra isn't just about a bunch of letters and numbers on a page. It's a seriously powerful tool you can use to describe and solve real-world problems. So now that you know the basics of its language, I'll leave you with this question. What problems will you solve? Thanks for tuning in.